On this F150 2.7 EcoBoost, P0203 may point to a possible injector circuit problem on the cylinder identified by the code. The driver may notice a rough idle, a misfire type feel, lack of power, or a warning light, and the condition can be intermittent. Broadly, this can involve the injector circuit, wiring, terminals, connector fit, power or ground integrity, scan tool command and response, or a possible control side issue.
Treat it as an electrical diagnosis first, not a parts call.
Before getting deep into P0203, start with the basic system checks. Look for anything obvious that matches the customer concern. Check for related service messages or bulletins, and look closely for previous repairs that may have been done incorrectly. Confirm the battery and charging system are healthy, and make sure battery SOC is greater than 70% before starting diagnostics. Then, scan the vehicle. If other codes are present, check what they mean first. Circuit-related faults get handled before performance-type faults, because a bad circuit can make the rest of the diagnosis lie to you. If the concern is not present during testing, do not condemn a module or another component from that test session. Next, inspect the electrical side like a mechanic, not just a code reader. Check the harness for damage, chafing, and routing. Check fuses, circuits, and connectors for continuity and correct installation, and make sure the related components are actually connected. If more than one circuit fault is present, look for a shared power or ground problem instead of chasing each symptom separately. Before you chase the injector circuit only, make sure the rest of the engine basics are not creating noise in the diagnosis. Inspect the vacuum lines and air intake system for leaks, routing problems, or restrictions. Look over the hoses for damage, leaks, blockage, and routing. Check fuel quality for octane, contamination, and winter or summer blend. Inspect the fuel system, including the tank and fuel lines, for damage, leaks, and routing. With the engine at the correct operating temperature, check coolant level and quality. Check oil level and quality for contamination and maintenance condition, and inspect the exhaust system for damage, restrictions, and routing. When you start making electrical connections, use the correct flex probes or terminal probe kit when connecting test equipment or jumper wires to pins, so you do not spread or damage terminals. Check male to female terminal fit with the mating pin and feel for normal separation force. If the connector shell, pin guide, or retainer is adding drag, remove what is needed to check the terminal fit correctly. If connector bodies, pins, or terminals are damaged, replace the damaged connector pieces. Use the scan tool to read PID inputs, output states, and diagnostic states. Data log the PID information so you can watch the fault without tearing the truck apart unnecessarily. Where the scan tool supports it, command outputs and watch how the system responds. Make sure you understand how the system is supposed to work. Confirm programmable parameters are correct for the function being tested, and if a DTC needs to be resolved first,
Handle that fault before moving on with symptom-based checks. Then, test the inputs, test the outputs, and check for module software updates.
If a commanded output works normally, that points you back toward the inputs and circuit conditions feeding the decision. Do not jump power or ground directly to module-switched components unless the test path specifically calls for it. Improper testing is how good modules get replaced for no reason. When checking a power-supplying circuit, measure voltage with the intended load connected when the circuit needs load testing. An unloaded circuit can look fine and still have excessive resistance. For circuits carrying approximately 200 to 1000 milliamps, load the circuit with a 250 to 350 milliamp test light and measure voltage with the DMM while the light is connected. Conductor sizes 24 gauge, 0.5 millimeters or smaller are generally used to carry approximately 1000 milliamps, 1 ampere or less, while conductor sizes 20 gauge, 0.8 millimeters or larger are generally used to carry 1 ampere, 1000 milliamps or more. For circuits carrying more than 1 ampere, use a load that requires similar current, like a brake light bulb. For higher current circuits, voltage drop is the better check. On ground circuits, measure voltage drop during component operation or attempted operation. If you use an ohm meter on a ground circuit, disconnect the battery first. Most small diameter 18 gauge and smaller wires are expected to have less than 2 ohms, and most wiring harness circuits are also expected to have less than 2 ohms. A standard DMM ohm meter's low resistance resolution approximately 0.1 ohm, limits its accurate use to circuits carrying less than approximately 5 amperes. If reversing the DMM leads changes the resistance reading and the circuit does not contain a semiconductor, treat that resistance test as invalid. To check for unintended continuity to ground, disconnect both ends of the suspect circuit and measure between that circuit and ground. The expected result is greater than 10,000 ohms. To check for unintended continuity to another unpowered circuit, disconnect both ends of both circuits and measure between them with an ohm meter. Again, the expected result is greater than 10,000 ohms. To check for an unwanted connection to a powered circuit, disconnect both ends of the suspect circuit, turn ignition power on, and measure between the suspect circuit and ground with a voltmeter. Back probing is only for cases where the circuit has to be tested under real operating conditions, or when a voltage drop check has to be made without changing circuit behavior. Even then, handle it carefully. Do not force probes into connectors, and use back probes designed for the job. A normal voltage drop test will show some voltage. The expected result is less than 5% of circuit operating voltage. Back probing is the wrong approach for a single-point voltage check, when 0 volts is a possible good answer, because you cannot tell a bad probe contact from a real 0. It is also the wrong approach for continuity or open circuit checks with an ohm meter. For those, disconnect and isolate the circuit and test normally. If you use jumper wires, always use fused jumpers. The recommended universal testing jumper wire fuse is 5 amperes or less, unless the load requires more. Use flex probes or equivalent to protect terminals. Follow the test directions carefully, but do not use flex probes to carry high current greater than 5 amperes. When repairing a circuit, find the fault, understand why it failed, repair the root cause, and repair any adjacent damaged wiring. Do not overlay a circuit without understanding the failure. For a voltage drop measurement, put the voltmeter across the beginning and end of the suspect part of the circuit. Operate the circuit, or at least attempt to operate it, so power is available to flow. Keep voltmeter polarity in the direction of conventional current flow. A 0 volt reading means the voltmeter connection is bad or the component isn't turning on. A small amount of voltage is normal circuit loss. In 12-volt circuits, normal loss is usually less than half a volt, and expected less than 5% of circuit operating voltage. Voltage greater than half a volt indicates abnormal voltage loss from high resistance in wiring or connectors. For a voltage in, voltage out test, connect the negative meter lead to ground or the battery negative terminal. Operate the circuit, then measure the power side and the ground side of the load. The power side should be within half a volt of battery voltage. The ground side should be greater than 0 volts, but less than half a volt. A result of 0 volts or supply voltage points to an open circuit. The takeaway for P0203 is simple. Prove the circuit under load, protect the terminals while testing, and let the measurements decide whether the fault is in the wiring, connector fit, power side, ground side, or command path. Do not guess, and do not condemn parts just because the code names a circuit. For more diagnostic training, visit stepdiagnostics.com.